What if the reality you perceive isn't the real reality? Let's take a moment to dive into the rabbit hole. We all believe we have a firm grasp on what's real and what's not. But quantum physics dares to challenge this belief. It compels us to question the very fabric of our perceived reality. Our senses, the tools we rely on to navigate through life, provide only a limited view of the world. They are, after all, designed to help us survive, not to unravel the mysteries of the universe. So what if there's more to reality than what meets the eye, ear, or touch? What if reality is not a fixed, tangible entity, but a constantly shifting, multi-layered phenomenon? This is where quantum physics steps in, like a key unlocking a door to a realm that is strange, yet undeniably real. A realm where particles can be in two places at once, where observing changes the observed, where everything is interconnected in a profound way. Welcome to the quantum realm, where the rules of the game are different. Imagine being in two places at once. Sounds impossible, right? Not in the quantum realm. Welcome to the strange and wondrous world of quantum superposition. Let's simplify this concept using a familiar object, a coin. When you flip a coin, it's either heads or tails, right? Now, imagine until the coin lands, it's neither heads nor tails, but both at the same time. This is the essence of superposition. In the quantum world, particles can exist in multiple states simultaneously until they're observed. Think of Schrödinger's cat, both alive and dead at the same time until we take a peek. This isn't some abstract concept confined to laboratories and textbooks. It's a fundamental aspect of reality, as real as gravity or the air we breathe. So what does this mean for us, for our understanding of reality? It means that reality isn't as fixed as we might think. It's fluid, unpredictable, and full of possibilities. It's a world where the impossible becomes the norm. Consider a photon of light. Before we measure it, the photon exists in all possible states. It can be here, there, everywhere, or nowhere. It's only when we look, when we observe, that the photon makes up its mind and chooses a position. This is the observer effect, another fascinating aspect of quantum mechanics. Our observation, our interaction with the world, shapes reality. It's a mind-bending idea, isn't it? We're not just passive spectators in the universe. We're active participants, shaping our reality with every observation, every thought, and every action. Superposition isn't just about particles or photons. It's about potential. It's about the infinite possibilities that exist until the moment of choice. It's about the boundless nature of reality and our place within it. It's a reminder that we're not separate from the universe, but intrinsically connected, part of the same grand quantum dance. In the quantum world, the impossible becomes possible. So next time you flip a coin, remember it's not just a game of chance, it's a glimpse into the heart of quantum reality. Can you ever be certain about anything? Quantum physics says no. Welcome to the world of uncertainty, a fundamental principle that governs the very fabric of our quantum reality. In traditional physics, we are used to the idea of certainty. We can predict the trajectory of a thrown ball or calculate the position of a planet in its orbit with a high degree of accuracy. But when we zoom into the quantum world, things start to get a bit fuzzy. Enter the uncertainty principle, the brainchild of physicist Werner Heisenberg. It tells us that we can never know both the position and momentum of a particle with absolute certainty. The more precisely we measure one property, the less certain we become about the other. It's like trying to pinpoint a buzzing bee in a dark room. The harder you try to locate it, the less you know about its speed and vice versa. This principle introduces a fundamental randomness and unpredictability into the fabric of reality. It seems counterintuitive, doesn't it? We're programmed to believe in a deterministic world where one event leads to another in a predictable manner. But in the quantum realm, certainty takes a back seat. Imagine you're holding a coin. In our everyday reality, the coin can either be heads or tails. But in the quantum realm, until you actually look at the coin, it exists in a superposition of states. It's both heads and tails at the same time. Only when you observe it, the coin collapses into one state or the other. This is the inherent uncertainty that quantum physics brings to the table. So what does this mean for us? It implies that at the most fundamental level, our reality is not set in stone. It's fluid, dynamic, and full of possibilities. It tells us that reality is not just what we see or touch, but a mysterious interplay of probabilities and uncertainties that shape the very essence of our existence. In the quantum realm, certainty is an illusion. The world as we know it is far more complex and fascinating than we could ever imagine. Step into the quantum reality and embrace the uncertainty. It's not just a scientific principle, it's a way of life. Is everything interconnected? Quantum physics suggests so. We're about to delve into the fascinating concepts of entanglement and non-locality. Now, you might be asking, what are these terms and why should I care? Well, these concepts are the backbone of the quantum world, and they're also what make it so downright strange. Let's start with entanglement. Imagine a pair of particles that are created together. These particles are inextricably linked or entangled, no matter how far apart they are. If you change the state of one particle, the other one responds immediately, even if it's on the other side of the universe. Weird, right? But it's not magic, it's quantum mechanics. Then we have non-locality, which is closely related to entanglement. It's the idea that an object can be influenced instantaneously by another object, no matter the distance. Remember our entangled particles? Well, they're a perfect example of non-locality in action. The change in one particle is felt by the other particle instantly, defying our classical understanding of space and time. So what does this all mean? Well, it suggests that at a fundamental level, everything in the universe is interconnected. The idea of separate entities existing in isolation is a construct of our limited perception. In the quantum realm, separation is a myth. But it's not just about particles and physics. These concepts have far-reaching implications for our understanding of the world and our place in it. They challenge our everyday experiences and force us to question our understanding of reality. If particles can be entangled, could our thoughts, our consciousness, also be subject to these quantum effects? In the end, the quantum world is not some distant, abstract realm. It's intimately linked with our everyday lives, influencing how we perceive and interact with the world around us. So the next time you feel isolated or separate, remember, you're more connected than you think. In the quantum realm, separation is a myth. What does quantum reality have to do with our consciousness? More than you might think. To understand the connection, let's consider the nature of consciousness itself. Consciousness, the very essence of our being, is a phenomenon that's baffled scientists for centuries. The human mind, with its ability to perceive, reason, and experience emotions, seems incredibly complex for something governed solely by classical physics. Now enter quantum reality, a realm that thrives on uncertainty, superposition, and entanglement. This is a world that doesn't bow down to the traditional laws of physics, a world where particles can exist in multiple states at once, influence each other instantaneously across vast distances, and even change their behavior when observed. Scientists have begun to speculate that this quantum weirdness might be at play within our minds. Theories like orchestrated objective reduction, proposed by physicist Sir Roger Penrose and anesthesiologist Stuart Hameroff, suggest that quantum processes in the microtubules of our brain cells could be the driving force behind consciousness. According to them, our minds might be quantum computers, using the principles of superposition and entanglement to process information in ways that classical computers could never achieve. Moreover, the fields of quantum biology and quantum metabolism hint at the possibility of quantum processes underpinning life itself. These disciplines explore how quantum phenomena might play a role in biological processes, from photosynthesis to bird navigation to the very functioning of our cells. Just imagine, if we could harness the power of quantum biology, we could revolutionize medical science. We could address diseases and aging at their quantum roots, opening up a world of possibilities for health and longevity. It's a fascinating idea, isn't it? Quantum reality is not just a distant, unrelated realm. It might be intimately linked to our thoughts, our bodies, and our very being. Your thoughts, your body, your very being might be more quantum than you realize. So why does quantum reality matter to you? You may ponder. Quantum reality is not just a scientific curiosity. It's not just an abstract concept discussed by physicists in their labs. It is, in fact, the fabric of the world that surrounds us and the essence of our being. It is an intricate tapestry woven with threads of superposition, uncertainty, entanglement, and non-locality. It's about understanding that our thoughts, our bodies, even the very essence of our existence, are all intimately connected to this quantum reality. It's about recognizing the unpredictability of our thoughts, the interconnectedness of all things, and the potential of quantum biology and quantum metabolism to revolutionize medical science. By embracing quantum reality, we open a new vision of possibilities. We see the world not as a collection of isolated objects, but as an interconnected web of energy and information. We realize that we are not separate from the universe, but a part of it. Quantum reality isn't a distant, unrelated realm. It's your reality,